Hello students, today we will discuss more about the superposition of linearly plane polarized waves at right angles. So here we have mentioned two plane polarized lights under whose plane of polarization involves z electric vector is vibrating in z direction and the other wave is vibrating in the y direction. And we have E2 and E1 as the amplitude of the both waves, and delta is the phase difference between them. And we have seen that the equation followed by the tip of the resultant vector after superposition of these two electric vectors at each instant is given by Ez square by E2 square plus Ey square by E1 square minus 2Ey Ez by E1 E2 cos delta equals sin square delta. Now we can see that based on the value of phase difference between these two waves, we can have different possibility for the equation of the circle or equation of the ellipse. So let us see first if the phase difference is 0, 2 pi, 4 pi, etc., or in general you can represent it as even number of pi, right? So you can represent it as 2m pi. Even number is 2m, then pi. So in that case, what will be the value of cos delta? Cos 0 is 1 and sin 0 is 0. So substituting that, we'll get it as what? Ez square divided by E2 square plus Ey square by E1 square minus 2Ey Ez by E1 E2 cos delta is 1. Okay, so this much would be present. And what is that? This much is available and this is equal to 0 for the first case. So what is this? It is of the form a square plus b square minus 2ab. Okay, so you can write it as a minus b whole square equal to 0, or you can write Ez as Ez by E2 is a minus Ey by E1 is a b value. Whole square is equal to 0. Now taking Ey by E1 to the other side, it is equal to 0. So taking that to the other side, it will become equal to. So here you can see that Ez is just E2 times Ey by E1. And what is this? Yes, you have E2 and E1 as the amplitude, those are the constants. So constant time, a varying thing. Okay, so this is of the form of a line, equation of a line, that is y is equal to mx, where m is the constant and x is the varying thing. So here you can see similar pattern is followed. So it is the equation for a straight line. That means the tip will be constituting a straight line at after traversing a different instant, and you can see it is having a positive values there. So what the resultant wave after passing through the crystal with a phase difference of 0 or 2m pi will constitute a plane wave. Okay, so if you have two plane polarized waves with a phase difference of 2m pi after traversing the crystal, it would behave as a plane polarized wave itself. So that is one possibility. Now let us consider the second possibility, where the phase can be 180 degree pi, that is pi, or 3 pi radians or 5 pi radians, or we can say those are the odd multiple. So you can represent it as plus or minus 2m plus 1 represent the odd multiple. So in that case, what is cos 180 or cos pi? It is minus 1. So it becomes plus term. And what is sin 180? It is 0. So similar to the earlier condition, only thing is that it is of the form a plus b whole square. So when we rearrange it, we would get it as Ez equals minus E2 Ey by E1. You can check it out step by step. So it is a straight line with a negative slope is obtained. So which is that? Yeah, the resultant wave will be a plane polarized line, but it would have been rotated by some angle. So it will be resultant wave will be in another direction. Now let us consider the next case where the phase difference between the plane polarized wave is 90 degree or 3 pi by 2 or 5 pi by 2 or in general even odd multiple of pi by 2. So in that case, considering the simplest one, cos 90, what is cos 90? It is 0. So this term will not be present, and sin 90 is 1. So what is the expression for us? Ez square by E2 square plus Ey square by E1 square equals 1. And what is this expression? It is the equation of ellipse. So we'll get a elliptically polarized line. So here you can see two waves, two plane polarized were just passed through a material, but at the end of the material, as the waves emerge out, we are getting a elliptically polarized light instead of the incident plane polarized light. Okay, so here you can see the beauty of generating a different state of polarization only by changing the phase difference it has been there. Okay, and for the same case, that is the linearly polarized waves are at right angle to each other, as well as these waves, suppose they have equal amplitude. So if they have equal amplitude, this become E1 square plus E1 square. Okay, E1 square in the denominator and here also E1 square in the denominator. So you can take it as a common factor and that will come to the right hand side. So the equation would be like Ez square plus Ey square equals E0 square. And what is this? X square plus Y square is equal to A square. What is that? It is the equation of a circle. Yes, so we'll be getting a circularly polarized wave. So it is a special case of superposition of orthogonal waves with same amplitude. Okay, if it is just orthogonal waves alone with different amplitude, you'll get an ellipse, while if they have same amplitude, you'll get a circularly polarized wave. Okay, so how do we get same amplitude? Yes, we have mentioned that Ey and Ez was possible if the light, say the light was incident in this way, that is parallel to the optic axis, then there is no inclination between optic axis and the plane of polarization of the incident wave, then it will be moving as such without any splitting. Okay, but if there is a angle between the optic axis and the plane of polarization of the incident wave, which is given by green line, we can see that there is a this incident light will be splitted along optic axis and perpendicular to the optic axis. So what will happen? You'll get two terms. One is Ey and another is Ex. Similarly, depending upon the angle, the amount of Ex and Ey will be different. Okay, so the splitting up into orthogonal components will depend upon what the value at which the value of the angle with which it is inclined with the optic axis. So here you can see that the same amplitude can be obtained in both the rectangular directions only if it makes 45, isn't it? Only if it is 45 you will get. So here you can see if it is 45, what will be Ey? Ey will be given by E0 cos theta, isn't it? So if it is E0 is the incident light beam, then along this direction you will get E cos theta or E0 cos theta, and along opposite direction of theta you will get E0 sin theta. So that is this direction, which is E0 sin theta. So when will this cos theta and sin theta will be equal? Then only this amplitude will be equal, isn't it? So cos theta and sin theta are equal for 45 degree. All other angle, it may have different amplitudes. Okay, so whenever the light, plane polarized light, is making an angle 45 degree with the optic axis, the two rays or the linearly polarized waves along x direction and y direction will have equal amplitude. Then once they superpose, you get a circularly polarized light. So you have to remember that point. Now let us check what are the inferences from the above discussion, that you can have an unpolarized light, different kinds of lights. One is, we have already mentioned, natural light is unpolarized light, or you can make it polarized using a polarizer, or you can make it partially polarized, and you can get elliptically polarized light, and finally you can get a circularly polarized light. So you can define an unpolarized light is due to resultant of two vectors which are incoherent, where there is no constant phase difference. Incoherent ആയിട്ടുള്ള waves ആണ്, plane waves ആണ് interfere ചെയ്യുന്നെങ്കിൽ അല്ലെ superpose ചെയ്യുന്നെങ്കിൽ we will get a unpolarized light. Okay, so you can consider this as a sequence of wave frames at random orientation, which is due to the which can be considered as a resultant of two optical vectors which are incoherent. But if they are coherent linearly polarized waves, they will superpose to produce plane polarized light. Okay, and if it is a mixture of those two, some are coherent and some are incoherent, then what you get will be a partially polarized light. And how do you get an elliptically polarized light? Yeah, if you have linearly polarized light which are perpendicular to each other, then only delta must be 90 degree. Then what you get will be, on superposition, you'll get elliptically polarized. So we should have two coherent waves. Coherent means their phase difference has to be constant, and they must have different amplitude, and their phase difference is given by 90 degree or any multiple of pi by 2. Then the tip of E, which means the resultant, will trace an ellipse. So such a polarized light is called elliptically polarized light. And for the same case, that is coherent on a constant phase difference of 90 degree under, but with equal amplitude anengil, the resultant wave will be a circularly polarized light. Okay, so these are the 5 different types of polarized light we have studied. So here you can see there is a vertically a polarized light where you can see the light is the electric vector is moving only in one direction, so it is a linearly polarized light. Here also you can see the red line, which indicates the vibration of electric vector, is moving along the horizontal direction, single direction along a line, hence it is called a plane polarized wave or a linearly polarized. So here what we have seen is, it is the wave that is moving, while here it shows the vibration of the electric vector. Okay, and another one is circular polarization, where you can see at every time the electric field is vibrating along different directions, and you are getting, that is resultant is along different direction, but it is having equal amplitude. So then you'll get a circularly polarized light. Now you can see a elliptically here this is also as circularly polarized light, where you can see one wave is there as vertical one, and another wave red is in the horizontal direction, and they have a phase difference of 90 degree. So once they superpose, if they are moving along the same direction, you can see they superpose, and the resultant will be following a circle, and hence that wave is said to be circularly polarized, and the resultant is shown by the purple color. Okay, so here again the resultant is shown by the arrow mark, and you can see it is moving equally in all directions. The length of the resultant is not varying. Okay, it's only because the amplitude of the interfering waves are the same. And the next you can see elliptically polarized ones, where you can see here red is a bigger amplitude one and blue is a smaller amplitude one. So once they interfere or superpose, interfere is not the exact term, you must specify it as superpose. So when such two plane polarized waves which are having a phase difference of 90 degree and with different amplitude superpose, you can see the resultant will constitute an ellipse. Okay, and hence the polarization is called elliptical polarization, and this orange line shows it is the resultant at each instant. Okay, so this is another way to represent it. Okay, so coming to our next topic, that is retarders. So what do you mean by retarders? So in the last concept you have seen that if there is two linearly polarized light, um, if they are falling on the optic axis, if you have a light which is falling on a crystal in such a way that it is, this is the surface, so let this be the optic axis. Okay, so optic axis is parallel to the surface and this is the crystal, and we have, let me point it as O, which is optic axis. So we have a light, an unpolarized light is actually made polarized using a polarizer. You had an unpolarized light, and let this be the direction of the polarizer. So then you'll get a sorry. So let me draw again. We have a crystal which is cut in such a way that the optic axis is parallel to the surface of incidence, and the light, a plain polarized light, is falling onto the crystal, and let it makes, let me draw it with a different color to indicate it as the incident wave. So here you can see the blue line is the incident light wave, the polarization of incident light wave. So here you can see it is making an angle theta with the optic axis. So in that case what will happen, we have mentioned the light waves will split up, and one in the perpendicular direction and other in the parallel direction. So these are the two rectangular directions parallel with respect to optic axis. So one will be called as so yeah, you have two different plane polarized line. So once they proceed, they will have different velocity and hence they will be having a phase difference or path difference. So corresponding to that, the amount of wave, the kind of wave that is emerging out will have different state of polarization. That is what we have discussed so far. So the same principle is used in retarders. So here you can see that a retardation, the phase difference is given by, what is phase difference? Phase difference is given by 2 pi by lambda into path difference. So whenever you can control the path difference, you can tune this value, and hence you can tune the amount of retardation that is going to happen. Okay, so how do you tune this? What is a delta, capital delta? Capital delta is the refractive index into the distance of the distance through which the wave is passing. So what is the distance through which the waves are passing? Yes, it is the thickness of the crystal, is the D. So if you have variable thickness, you can make different values for phase difference or path difference. So correspondingly, we can have a different kind of retardation between the two orthogonal waves. Okay, so that is the concept implied here. First thing is that the crystal must be cut in such a way that the optic axis is along the incident plane. Then only we can expect this kind of motion. That is, when the ray proceeds, it will be perpendicular to the optic axis, isn't it? So what happens whenever a ray is moving perpendicular to the optic axis? The both rays, extraordinary and ordinary rays, will be moving in the same direction but with different velocity. That is what we have seen. But if they are along the same direction of optic axis, they will be having same velocity. That is what you mean by optic axis, isn't it? So only when they are moving perpendicular to the optic axis, they can move in the same direction. Only if they are in same direction, they can superpose and produce different state of polarization. Okay, So that is a point to be made clear. So first you have to mention the optic axis, and then you can mention about the thickness, which can decide what is the phase difference or path difference that is going to constitute after passing through the material. Okay, so keeping that in mind, we have two kind of retarders. So what is retarders? Those are the materials which can change the state of polarization of an incident light. So how do you change the state of polarization? Only because based on the thickness of the film. So let us see the quarter wave plate. So quarter wave plate, from the name itself, there will be a path difference of quarter wave. Okay, so what is a quarter of a wave? Quarter of a wave is given by lambda by 4. So after traversing through such a material, the plane polarized light would have a path difference of lambda by 4 as they emerge out. Okay, so what will happen if there is a path difference of lambda by 4? Let us just throw away and let's check what is lambda by 4 corresponds to. Okay, so this is 0 and this is lambda by 4 of wave. So what is this point? What is the value of phase value? Phase is given by how much? Yeah, it would correspond to 90 degrees, isn't it? What is 90 degree in radians? It is pi by 2 radians, isn't it? Okay, so whenever there is a phase difference of pi by 2, what kind of state of polarization will be emerging out? Yes, we have studied that. You'll get a elliptically polarized light or circularly polarized light depending upon the amplitude. Okay, so the same principle is applicable here. So we can see that for a quarter wave plate, the path difference between the plane polarized waves would be lambda by 4 after passing through the thickness of the material. So what is path difference? It is given by mu E minus mu O, which are the two orthogonal waves, into the thickness, that is D, is equal to lambda by 4. So from this you can calculate what should be the thickness of the plate required to work it as a quarter wave plate. And what is the function of quarter wave plate? What is it doing? From our earlier discussion, you can see that a quarter wave plate can produce a phase difference of pi by 2 between extraordinary and ordinary ray. So if there is a phase difference of pi by 2, you can get either an elliptically polarized light or a circularly polarized light. So what will you give a circularly polarized light? The extraordinary and ordinary ray must have same amplitude. How do you get a same amplitude wave? Yeah, the incident plane polarized light must make 45 degree with the optic axis. This is the dotted line is shown as the optic axis. So here you can see the plane of vibration of the incident wave is making 45 degree. So then that means there will be equal amount of resolving into the two direction, and you get it as same amplitude and hence a circularly polarized light. If it is other angle than 45 degree, then you will get what? Then you will get elliptically polarized light. So here you can see that a plane polarized light is converted into a circularly or elliptically polarized light by just passing it through a material which has suitable thickness. Similarly, half wave plate. So in half wave plate, can you just explain half wave plate? Yeah, in half wave plate is such a material, or it is a retarder which has, first you have to mention about the optic axis. What is it? The optic axis is parallel to the incident surface, so that a plane polarized light incident at an angle theta making with the optic axis will split along EX and EO, or EO and E rays, and once it travels through the thickness of the material, it would have a path difference of half a wave, that is lambda by 2. Now what is lambda by 2 corresponds to? Yeah, half of the wave means this much amount. That means a phase difference of pi. So you'll get a phase difference of pi. So whenever there is a phase difference of pi, what was the condition? Yeah, you'll get a plane polarized light, but it would have been rotated by a small amount. So let us see how it is possible. So such kind of retarders are constructed out of quartz crystal or a biaxial crystals. So in problem session you can expect questions from this part and you can see that it could be asked like what is the thickness for obtaining a elliptically polarized light when a plane polarized light is passed through a quartz crystal. So what is your answer? You have to infer that it is about quarter wave plate, and then you can use this equation. And for half wave plate, what would be D? It would be this one. So part we have mentioning, so it is lambda by 2 into mu e minus mu. The same thing you have done for quarter wave. Okay. So it might be question could be like that. What is the thickness for which a plane polarized light may be rotated by 2 theta after traversing through the such a plate? Okay, so we are asked to find out what is the thickness. So then you have to infer that it is about half wave plate, and then you can make use of this equation. Okay, so remember that point. Now let us conclude how this half wave plate makes a rotation of 2 theta. So here you can see this red line represents the plane of polarization, and you can see it is the plane of polarization of the incident wave, and at the incident surface you can see it is splitted up along blue direction and along green direction. So you can say a green wave is proceeding, just doesn't mean that there would be a green wave, just a pictorial representation that one wave will be proceeding in this direction, another wave will be proceeding at a 90 degree with the first wave. Okay, so once it reaches the other end of the crystal that is shown here, what is happening? It is a half wave plate. Half wave plate means it should have undergone a phase difference of pi. So let us consider the light was, so here the green wave was upward and the blue wave was towards right, isn't it? Now let us consider the blue wave. Let us keep one wave constant and let us give the phase change to the another wave along. Okay, so green was actually above, vibrating above during the incidence, but now after it emerges out, since due to the pi phase difference, it will be vibrating in the downward direction. So what would be the resultant of this downward vibration and the rightward vibration? So it would be like this: downward vibration of green wave and the rightward vibration of blue wave. So what will be the resultant? Yeah, the resultant would be along this direction, or you can extend it, so it would be like this direction. Okay, so initially the wave was like upward for the green wave and the rightward direction for the blue wave. Okay, so the resultant was along this direction, but now as it emerges out, one wave is kept constant, another wave will have rotated by 180 degrees. So upward nu pagaram downward aanu nammal consider cheythu. So the resultant will be along this direction. So how much is the polarization that being rotated? You can see initially it was like this with upward bend, upward vibration, and now it has rotated by this much amount. So that would be like 2 theta. So that is how we get 2 theta rotation once it passes through a half wave plate. Okay, so that ends the topic for today, and you can just go through the essay. Thank you.